Hi, I'm Bingyao. Last time we have talked about the solar grid parity. Today we are going to discuss the consolidation in solar upstream. Solar upstream consists of solar-grade polysilicon and wafer. Mass production of solar-grade polysilicon started in early 2000s when the German government firstly ramped up the promotion of clean energy. Chinese government has instigated a push to take over global demand and supply since 2013. After that, we have seen Asian companies, especially a number of Chinese companies, stepped into the history, in which GCL Poly Energy is an important company who was dedicated to polysilicon cost cut. GCL pioneered key equipment import substitution and production method improvement to ultimately cut machinery investment in addition to materials and energy consumption. Some followers subsequently located their new capacities in West China, where power cost is as low as 0.2 RMB per kilowatt hour. They further reduced the cost by a series of capacity expansions to enjoy the economy of scale. LONGi Green Energy is another vital company in wafer part. Similar as GCL, LONGi made great contribution in equipment manufacturing domestically to cut the fixed investment. They were the first to adopt the diamond cut line and bring in mono wafer to mass production. It significantly improved the solar cell conversion efficiency and reduced solar cost in terms of LCOE. We have seen polysilicon and wafer price decline by over 90% in the last decade. Chinese players' cost advantages as well as supply chain coordination and collaboration help them keep gaining market share in the world. In terms of capacity, the top 5 Chinese polysilicon producers' market share reached 56% in 2019, compared to 11% in 2010. And the top 5 wafer makers' global market share increased from 20% to 70% during the same period. Polysilicon production is a typical chemical purification process with 4 key inputs: metallic silicon, purification equipment, energy, and labor. China enjoys the lowest cost in metallic silicon power and labor. After substitution with domestic equipment, Chinese players established the absolute cutting edge in global competition. Solar-grade wafer production is essentially a fine manufacturing business with 4 key inputs as well: solar-grade polysilicon, equipment and auxiliary materials, energy and labor. Similar to polysilicon, after China could produce key equipment and auxiliary materials by their own, Chinese wafer makers had mastery over all the chip inputs in massive production. It results in further cost advantages in lower logistics cost and less frictions in tariff and supply chain stability, coupled with leading polysilicon production. In the long term, there are a few ways to cut production costs in solar upstream. Firstly, equipment innovation to reduce energy consumption and unit cost. Secondly, economy of scale to lower fixed cost amortization. Thirdly, revolutionary changes to silicon-based solar cell. Moreover, purification method improvement and more efficient wafer could also help reduce the cost in polysilicon and wafer respectively. We will keep our eye closely on technology innovation and would like to hold a conservative view on who will ultimately succeed in the long term, although the current cost leaders are likely to keep consolidating their leading positions in both technology and cost cut.